Hello, good morning. I'm Dr. Sonali here. We are here on Education on Cloud. For class 10 science, we have quick revision for the chapter 10, which is light, reflection and refraction. Okay. So what is ray of light? A line drawn in the direction of propagation of light is called ray of light. Okay. It can be like we can show just a source of light like this, which is a parallel beam, okay, or we can show this light is passing through some medium and getting changed, then or we can show this ray of light is passing via prism, anything. Ray of light is a line drawn in the direction of propagation of light is called ray of light. Okay. Now the beam of light is a group of ray of light emitted by a source of light is called beam of light. The light beam can be three different types. One is called parallel beam, divergent beam and convergent beam. Parallel beam is like this, a group of light parallel to each other. Okay, here they all are parallel to each other, so this is called parallel beam of light. Divergent beam, a group of light spreading out from a source of light, which is called divergent. Like here there is a source and from here all the light rays are starting, so this is called divergent beam. Convergent beam, a group of light rays meeting at a point. Now all the rays are meeting at one point. Okay, so this is, are you understanding the difference between these two? Now here it is coming out from this point and here they are meeting at this point. So this is the difference in convergent and divergent. So the group of light rays meeting at a point is called convergent beam of light. Okay. Now reflection of light is, there are some surfaces which has ability to send the light back to the same medium when the light strikes it. This phenomena of sending the light back in the same medium by a surface is called reflection of light. Like this is the surface is mirror here, so incident rays falling on the mirror and getting reflected. Okay, so this is called incident ray, which is coming, which is going, hitting and going back is called reflected ray. Okay, and this is called normal. So now we can see here the reflection of light. If we say here, there are some surfaces which has ability to send the light back in the same medium when the light strikes it. Okay, so phenomena of sending the light back at the same medium by surface is called reflection. So this is the light rays coming and hitting to the mirror and getting reflected, so this is reflection. Now the incident ray, the reflected ray and the normal, there are three rays we are discussing. One ray which is coming to the mirror is called incident ray. One ray after hitting to the mirror it is getting reflected, that is called reflected ray, and there is in the middle, this is called normal. Okay, so the incident ray, reflected ray and the normal at the point of incidence all lie in same plane. Okay, and the angle of incidence is always equal to the angle of reflection. We can see here. Now here this is incident ray, this is reflected ray, this is the surface is mirror, and in the middle there is normal. So this I and R, it is called angle of incidence is for I and angle of reflection is for called R. So I is equals to angle of I is equal to angle of R always in this case. Then what is image? How image is forming? When light rays meets or appear to meet at any reflection from the mirror, then only it is called image. Okay, so real image or virtual image. Now how real image is formed? Real image will be generally inverted and it is obtained from convex lenses, and the virtual image is always erect image and it can be obtained from convex or concave lenses also. So it is a kind of image which is formed by actual intersection of light rays after reflection, that is only called real image. Then the virtual image is a kind of image which is formed by producing the reflected rays backwards after reflection, that is called virtual image. Okay, then what is plane mirror? The plane mirror is a piece of glass whose one side is polished by using silver paint, then which is covered by coating of red paint to protect the silver layer. Okay, that is called plane mirror. Spherical mirror is, it is a part of hollow glass sphere whose one surface is polished, and there are two types of spherical mirror. One is concave mirror, one is convex mirror. So let us see here, in both the mirrors we can see here reflecting surface is for this concave mirror is reflecting surface is inside, and for convex mirror is reflecting surface is outside of the curve. So let us see, it is a spherical mirror whose outer surface is polished and inner surface is reflecting surface. So the inner surface is reflecting surface. Okay, we can draw with the another color also, and we can say here this is reflecting surface. Okay, like this, and here this is reflecting surface, okay, like this. Then convex mirror is a spherical mirror whose polished inner layer is polished and outer side is reflecting surface, okay. Now difference is clear. Then what is principal focus? A point on the principal axis of spherical mirror where the rays of light parallel to the principal axis meet or appear to meet, that is from the reflection from the mirror. Let us see this picture. Now in this picture we are getting this point is called principal focus, okay. So principal focus is the distance between, now focal length also we are talking now. Now focal length is distance from this to this is called focal length. So focal length is distance between pole P and the principal focus of a spherical mirror is called focal length of the mirror. It is denoted by F. So we are showing F here, which is from here to here. This distance is called focal length, okay. Now uses of concave mirror, where concave mirror can be used. It is used as a shaving mirror, which is because when it is placed close to the face it forms a large image, okay. Second is it is used in solar heating devices like solar cooker, because it converges the sun rays over a small area to produce very high temperature. So that is only required in solar panels. So it is used for security checking purpose also. So these are the mirrors, concave mirror applications. Now use of convex mirror, if we talk, there is rear view mirror in automobiles. In the vehicle there are rear view mirror because it gives erect image as well as diminished, due to which we had wider field of view. So whichever vehicle, like a person who is sitting on the driver's seat, that person should be able to see which vehicle is coming from the behind and how many vehicles at a time. So it is giving a wide view. So it should not be like only one vehicle is seen in that mirror and other vehicles are not seen. So person can do accidents in that case. So that is why there is a wider field of view is required in this case, okay. Now here it is also used in street lights, convex mirrors, okay. So what is mirror formula? How to calculate? It is a relationship between distance of object, distance of image from the pole of the mirror and its focal length. We can calculate everything in this: distance of object, distance of image and focal length by this. So relationship between u, v, it can be given 1 by v plus 1 by u is equal to 1 by f, okay. Now what is magnification? Defined as a ratio of height of image to the height of object. It is denoted by m. So m can be calculated as size of image, ratio of size of image to size of object, h naught by h or is equal to v by u. That can be given magnification. Now refraction of light. We have just now discussed reflection. Now refraction. Refraction means, now suppose incident ray is falling in this surface and then it is getting refracted, deviated from the direction, that is called refraction. Like the bending of ray light when it passes from one medium to another. So like here the medium was suppose air, and from air to it is going to water. So the you can see anything, suppose for example in a beaker which is filled, half filled with water, you are putting one pencil in that beaker. Observe it from far, you will observe it, pencil will look, when above the water level pencil will look in the direction which you have put it, but below that it will look little bended. So pencil is straight only, it is not bending, but because of this refraction of light we can see that way, okay. So from one medium to another, that is only called refraction of light. So like laws of refraction, the incident ray, refracted ray and the normal. Now see, incident ray, ray which is falling, refracted ray, ray which is bending, and the normal which is in between, okay. So there are three types of things which we are discussing here. At the point of incidence all lie in same plane, okay. And then when a ray of light undergoes refraction, then the ratio of sine of angle of incidence to the sine of angle of refraction should be constant, okay. Now the refractive index, what do you mean by refractive index? The refractive index of medium 2 with respect to medium 1 is given by the ratio of speed of light in medium 1, okay, and the speed of light in medium 2. This is usually represented by symbol N21, okay. This can be expressed in an equation form, like we can say N21 is speed of light in first medium by speed of light in second medium, because light is coming from first medium getting bended to the second medium. So that is only speed of light in first medium, speed of light in second medium, v1 by v2. So refraction by spherical lenses. Lens is a transparent medium which is formed by joining two pieces of spherical glass. Then there are two types. One is convex. It is the lens which is thicker at the center and thinner at the edges. Okay. Then concave lens, which is thinner at the center and thicker at the edges. I had shown you the diagram also. Now terms related to the lens. Optical center of lens, it is the center of the lens through which light can pass without any deviation. Okay. Principal axis, it is the line passing through the optical center and is perpendicular to the line joining to its edges. That is only called principal axis. We have seen one diagram just now. Principal focus, it is a point on principal axis where all light rays which are parallel to principal axis either converge or appear to be diverge from the after refraction. Okay. Now lens formula, we have just now used it. 1 by v minus 1 by u is equal to 1 by f. Okay. Now magnification, m is h2 by h1, ratio of height of image to the height of object. It is the given by v by u, ratio of distance of image to the ratio of object, like size of image by size of object. That can be h dash by h or h2 by h1 or v is equal to v by u. Can be also. Now how to calculate power of lens? A beam of light parallel to principal axis either get converged or diverged after refraction by a lens. Some lenses converge the beam of light to a small extent and some converge it to the larger extent. So the ability of lens to converge or diverge is only known as power of lens. Okay, like when you are wearing spectacles for farsightedness or for the reading glasses, so there is some specific power when you use it. So that power is only calculated by the how much vision is proper and how much vision is not proper. To correct that, that kind of lens is been suggested to you to wear it. Okay. Then SI unit for power of lens is diopter. Diopter is, one diopter is the power of lens whose focal length is 1 meter. Now power of a combination of two or more lenses. If two or more lenses are placed together to form a combined lens, then the power of this combined lens is equal to the sum of power of individual lenses. You would have heard about bifocal lenses also. In the same lens, the upper part is seeing for farsightedness, the bottom part there will be one semicircle kind of part which is used for reading. So sometimes it causes a lot of illusion, that kind of lenses, but that is only we are talking here combination of two or more lenses. Then P is equal to P1 plus P2 plus P3 will be the formula here for calculation. Thank you.